All right, we're going to talk about an idea that's an existence theorem. It's called the intermediate value theorem. And if please don't think too hard about this, because this is mostly common, the idea of a common sense kind of theorem. And so let's suppose these conditions are true for a function. F is continuous on a closed interval from A to B. And so essentially what I'm talking about is there's a point at A and there's a point at B. That's what it means by closed interval. And it's continuous. So let's go ahead and draw in. So here's my A down here. And so I come up, I can come up, down, doesn't really matter. But notice that there's no breaks, no holes, no asymptotes, vertical asymptotes, no jumps, no weird stuff like that. So even though I have a silly little curve going on that kind of goes up, down, it's still technically continuous. The next thing I want you to notice is that my points, my y coordinates are not equal. F of A and F of B are not the same. They're two different y values. And let's say that I have some sort of k, which is an x value between, or sorry, there's an x value between, y value, that there has to be some sort of y value, so some y value in here. So we can pick, we'll pick this guy. There's my k. And there has to be some sort of c that creates that k. So I need to have, if I have a y coordinate, there's a y coordinate that's between f of a and f of b. There has to be some sort of c that's that creates, that's the order pair, the x version of that order pair for that y coordinate, which is k. Be careful, as long as the function is continuous and the endpoints don't have the same y value, then the function has to take on every y value between those two endpoints. So what that means is I can't go here and then jump up here and completely delete the y values that are located between those jumps. Therefore, it's just not continuous. So a little bit of what the intermediate value theorem says is it takes on every y value you can think of that happens between my first, I'll go ahead and take this out, from here, a y value that starts here and here. Every y value that starts from f of a to f of b, there is a y value that exists there. And then if there's a y value, there has to be his ordered pair, the x. And that's what the intermediate value theorem is stating. Alright, let's go through several examples. Number one, use the intermediate value theorem to show that f of x is equal to x to the third plus 2x minus 1 has a 0 in the interval from 0 to 1. Now, again, remember, all polynomials are continuous on any closed interval. They're going to be continuous on any open interval. So we don't have to worry about some crazy jumps, breaks, or anything like that, or holes. So polynomials are really, really nice to work with. In this case, I talk about has a 0. Well, that has a 0 is going to be my k. That's my y value. So right now we're looking for where k is equal to 0. So I want to find that there's going to be some sort of x with that order pair. Here's my y of the order pair. I need to find, essentially I want to prove that there's an x for the order pair. And so let's prove using the IVT, the intermediate value theorem, to show that 0 exists. So we're talking between 0 and 1, so let's find f of 0 and f of 1. F of 0 is going to be equal to negative 1. F of 1 is going to be equal to 1 plus 2 minus 1, which is 2. Now we have to use a little bit of common knowledge here. I have a negative here, right? And I have a positive here, right? Well, in order for if I have to go from a negative y value to a positive y value, I have to, here, I'll draw it out for you. If I go from a negative y value to a positive y value, I have to cross where y is going to be equal to 0. If I'm going to connect these are continuous. I don't really care what's going on between them, but I have to cross the x-axis where y is going to be equal to 0. And so since my function goes from negative to positive, there has to be some sort of k in there. There has to be some sort of y in there. If I'm going from on the horizontal number line from negative to positive, there's a 0 there. And so since f of 0 is negative and f of 1 is positive, by the intermediate value theorem, there has to be a k such that k is going to be equal to 0. Okay, so that's the first one. Number 2, a car travels on a straight track. During the time interval from 0 to 60 seconds, the car's velocity v is measured in feet per second and is a continuous function. So that's good. So no brakes, no holes, no jumps. The table below shows selected values of the function. So we have t on the top, v on the bottom. Just as a side note, if you remember in physics, velocity can be negative because we're talking about going in, I call it the wrong direction, but essentially means moving to the left versus the right, so that negative has to do with a direction, not necessarily or going below sea level versus above sea level. So that's where velocity is negative. Speed, on the other hand, it doesn't really matter. Speed doesn't care what direction you go in. He's always positive. And so if you notice, initially with my values, my velocity is decreasing. So I must be going further to the left. And then somewhere around 15 seconds, I must turn around, because then my velocity is increasing, and it increases and keeps on increasing all the way throughout the interval. And so what they want us to show is for values from 0 to 60, must there be a time t where v of t is equal to negative 5. And so if you're thinking about driving in a car, there's no way that if you're talking about velocity, when you're driving in and you're talking about negative, if you're talking about, feet per second, you can't just jump over 4 feet per second to 5 feet per second or negative 6 feet per second, and then all of a sudden your speedometer just jumps to negative 4 feet per second. That doesn't make sense. You have to actually go through negative 5. So it says it's a continuous function, so let's just look at where negative 5 might occur. And if you notice, negative 5 is somewhere in here. Somewhere between 35 seconds and 50 seconds. I know that because I'm talking about my v is going from negative 10 to 0, and negative 5 would be on that interval. And so there has to be a time t. So since v of t is continuous, on the open interval from 0 to 60, and at t equals, oops, that's not what that says, at t equals 35, v is equal to negative 10. And t equals 50. And v is equal to 0. There has to be a v, well, we'll say it this way, a t such that v is equal to -5, and that is the intermediate value theorem. Number 3, let f of x be continuous on the function on the interval from -2 to 2. Using the value or table of values below, determine which of the following statements must be true. And so if you just look at the x values, it looks like we're going -2, -1, 0, 1, and 2. F of x is -4, 1, 6, 3, and -5. And so let's kind of look through all of our conditions. 1, f of x takes on the value of 5. So let's see. Is there y values that show that 5 might show up on our interval? And so I look and I notice I'm going from 1 to 6. Well, I know it's continuous, so in order to get to, if I start at 1 and I get to 6, I have to hit 5. So part 1 has to be true. Part 1 has to be true. If I'm going from 1 to 6 in y values, in order to get to 6, I have to go through 5. Number 2, a 0 of f of x is between -2 and -1. So let's look. Between -2, my y value is -4. At x equals -1, my y value is +1. If I'm going from negative y values to positive y values, I have to go through 0. And so a 0 of f of x is between -2 and -1. That is true. Because in order for me to go from that -4 to +1, that y value has to, at 0, has to occur. So number 2 is true as well. Let's check number 3. A 0 of f is at 6. And so I need to look at x equals 6. Well, my interval only goes from -2 to 2, so there's no way that I can look at 6. Most students probably will make this mistake right here, and they'll say 0, they see 6, and they're like, oh yeah, that's true. Well, when we talk about a 0, we're talking about where y is equal to 0. In this case, y is equal to 6. X is equal to 0. And so they kind of trying to trick you. They're flipping the ordered pair on you. Instead of having 6, 0, they put in the table 0, 6. So please be careful with that. They're going to try to trick you. So number 3 is not true. So in this case, it's going to be D. D will be the correct answer.